Hello and welcome. My name is Anthony, and this is Fluorescent Learning. In this video, we'll discuss what modules are, a couple built-in Python modules, how to create your own modules, different ways of importing them, and then we'll finish off the video with a little project. You may be wondering, what is a module? Well, a module is just a Python file that contains functions, classes, or variables that we can use in our code. Modules help us organize our code by separating it into different files instead of having one really long file with like 1,000 lines of code. Using modules allows our code to be more reusable and allows our code to be easier to maintain. If we know one part of the code isn't working, instead of searching those 1,000 lines of code, we just go to that one module file where it's broken. You can think of modules sort of like toolboxes that hold certain tools that we can use for any job. Python has built-in modules into the language already, and we can also create our own modules. Let's see two built-in modules called math and random. Let's go ahead and make a new file. We'll call it modules.py. Alright, let's begin. So we'll start with Python's math module. Now to use a module in your code or file, you say import and then the name of the module. And now we have access to all the functions within the math module. Let's go ahead and access some functions in the math module. Let's say I wanted the square root of a number. Without the math module, in order to get the square root, I would have to do something like, we'll take 4 to the power of 1 divided by 2. Yeah, and we get 2. 2 is the square root of 4. But we can use this math module here, and it has a built-in function called square root. So let's replace this, and we'll say math.square root, and then we'll give the number that we want a square root of. Let's go ahead and print it. And look at that, we get 2, 2. 2, 2. We get 2 also. Let's try again with 16. We should get 4. Square root of 16 is 4. And it works perfectly. There's other functions inside this math module. I can print the constant pi, or just say math.pi, and we get a pretty decent amount of decimals for pi. I don't know if that's accurate. I don't know all the numbers of pi. I just know 3.14. Another module we can import is the random module. And you can import as many modules as you need in your code. So to import another one, we'll just say import and then random. And the random module just sort of helps you do random things. So I can print random.randint, and that's short for random integer, from 5 to 100. And this should give me a random integer from 5 to 100. Let's go ahead and run it. And there we go, I get 24. If I run it again, it's 42, the last number, 77, 87. You see it's just changing randomly. So let's make a file called calculatormodule.py, and if you haven't guessed, it will be a calculator. Alright, now let's speed run this and go ahead and add a add, subtract, divide, multiply function. Okay, there we go. I added this exponent one just for fun, I guess. So now we have this calculator module that we made, right? And as you see, it's just defining all the functions. We're not actually doing anything with the functions. So within our modules.py, we'll bring in the calculator module that we just made, so we can refer to our calculator modules and access the functions within it. So let's go ahead and delete all this, and we'll import our calculator module. It's as easy as just saying import and then the name of your file. So we know our functions were add, subtract, multiply, divide, and exponent. Let's try using a couple of them. We'll say print, we'll give the name of our module. We use the dot to access functions inside of it. And you see we have the list here of all the functions we made within our calculator module. We'll say add, and then we'll pass the arguments of 2 and 4, and then we'll go ahead and try the one that I made and say exponent, and we'll say 4, 2. So print, we're accessing this module, and then we get the function add inside of our calculator module after importing it, and we pass arguments 2, 4. That refers to this calculator module file here, and then we have our add function. We pass 2 and 4 as arguments, so it should return 2 and 4. And then here's our exponent returning 2. Oh wait, what did I have? 4. So it's 4 is the first argument, 2 is the second, and it returns 4 to the power of 2. So for this first line, we should get 6 printed, And for the second one, we should get 16. And there we go. Works perfectly. So here, you see how I import calculator module, but what if we don't want to keep tidying the entire calculator module? You can use what's called an alias. So I can say import calculator module as C, because it's faster to type. And then here, instead of having to type the entire calculator module, I can just type C. The module is now referred to as C. I still use this dot notation, dot, and then the name of the function to access the functions inside of that module. And just to show you it works, if I run it again, there we go, 6 and 16. Now this method is importing the entire calculator module, but if I know what functions are inside that module and I don't need the subtract, multiply, divide, all the other ones, I just want the add, what I can do is, instead of importing the entire module, I'll just leave it up there so we can compare. I'll say from calculator module import, and then the name of the function. Now we'll get squiggly line VS Code saying it doesn't know what C is because we commented out that line of code. But down here I can just print add, and then we'll pass different arguments, 4 and 5. And look at that, we get 9. So VS Code or Python knows that this add function is referencing or referring, I keep getting those words confused, referring to this calculator module. It pulled the add function from our calculator module, and we now have it within our modules.py file. And I can import more than one function. If I also wanted to import, say, the subtract function from our calculator module, I can just add a comma and then the name of another function that I know that is in that module. And I can do the same print, and then we'll access our subtract function, and we'll say 5 and 4. That last line should give us a value of 1. Just like with the alias we have here for the entire module, we can also give an alias to a function that we import from a module. So if I had another subtract function and I didn't want to confuse it with the subtract function in this file with the one I have in our calculator module file, I can give it an alias. So let's just say we have another function here and we also call it add. So if I'm importing add, there's this add function here and this add function here have the same name, so Python can get a little confused. So what we can do is give the add function from our calculator module an alias, just like we have with this first line. And I can say import add as A. And now you see we get this squiggly line saying it doesn't know what incarnations this is. So then I just say A, and I'll go ahead and run it, and we get the same, 9. So let me go ahead and show the, I guess, 4 different ways of importing. I'll do a quick speed run. Okay, so here they are. This first one is importing the entire module. This second one is importing the entire module using an alias. So you refer to it as C, like we have here, C dot, and then the name of the function you're trying to access. This third one imports just a single function from your module. And then this last one, as we have here, imports a single function from your module using an alias. There's also one last way of importing, but from what I read, I don't think it's really recommended that much. I'll go ahead and show it. You say import the name of your module, and then you give it a star. But I did that backwards. You're supposed to say from the name of your module, you import, and then you give a star. Let me go ahead and comment this line out so it doesn't run. Now what this star does is you're telling Python to import all of the modules or all of the functions from your module. So here now I have access to add without using the dot notation that we have here. Just like I did here where I was saying give me the add function from the calculator module using this import star notation, I'm saying give me all of the functions from that module and I'll use those names. So I don't have to use this dot notation. I can just refer to the functions by their name, and I can show you. See, we can say subtract, and you see we get no errors while calling this. Whereas if I comment it out and use the just import method, you see we get those squiggly line errors saying that it doesn't really know what those functions are. I think from what I've read, using this notation, the reason it isn't recommended is because it imports everything from that module. And like I said earlier, when the add functions. If there's a function in that module that has the same name as your function, Python can get sort of confused on which to use. So I guess maybe just forget I showed you that. I don't know. For the project for this video, we'll make 2 Python files. One will be our main file, and the second one will be a temperature converter module that we'll create. So for the main file, we'll get input from the user for the measurement that they have and what they're trying to convert to, whether it be converting to Celsius or Fahrenheit. Then we will import our module and use our second Python file to do the conversion. Let's try it out. So let's change these names since I've already created these files. Let's go ahead and rename this to temperature converter, and then we'll change our modules to main.py. So in our temperature converter, we'll need a function to convert from Fahrenheit to Celsius. Okay, I have to do a quick search because I forgot how to convert that. I know it's 9/5 and something. Wait. I think it's times 9/5 plus 32. Let me check. Quick Google search. No, I got it backwards. Okay, so it's actually the temperature times 5 divided by 9 minus 32. Wait, I probably did that wrong again. Yeah. So it's the temperature minus 32 times 5 divided by 9, right? Google says yes. So that's to convert from F to C, and then to convert from Celsius to Fahrenheit, we do the opposite. Okay, let me just double check that I'm doing that right now. C to F conversion times 9/5 plus 32. We're good. So we have our temperature converter. In our main.py, we'll import our temperature converter, and then we'll get an input from the user. Let's first figure out which temperature they have. So if they have Fahrenheit, we want to convert to Celsius. So I'll say, what is your temperature measurement in? And then we'll have C or F. Or maybe I should put like a cool way, C for Celsius, and then F for, oh man, how do you spell Fahrenheit? Fahrenheit. So let's change the name of this variable just to make a little more sense. We'll say this is the measurement, I think that's what you would call it. No, unit. Let's call it unit. Okay. Then we will get the actual temperature, and we'll convert it to a float. And then we'll ask, what is the temperature? The temperature to convert, or you're converting, I guess. All right, now let's check. If they give us C, then they're giving us Celsius, and we want to convert that to Fahrenheit. So we will print, and we'll call our function. We have to call or access our module. Within our module, we will convert C to F, and then we will pass in the temperature. First we'll say, let's give the temperature they gave us. So we'll say F is, let's go ahead and say this is C, and then we'll give that argument, and then we'll close our string, and then we'll do the same for Fahrenheit. And then if they give us something else, another answer as unit of measurement, we'll just say IDK what that is, man. Let's do this so it'll run until they stop, or until we stop the program. So we'll say while true, just so it has a little more oomph to it, a little more flavor for this code. And then once they give, we'll go ahead and break. All right, let's check to make sure this would work. We import it while true. We ask what's their temperature measurement, temperature unit of measurement. Yeah, that sounds better. Then we ask for the temperature, and then we check which unit of measurement they're giving. If they give us something else besides CF, I say they. It's me running the code. And all right, let's try it out. What is your temperature unit of measurement in CF? So I'll give G, just see if it works. What is the temperature you are converting to? I'll say 100, and it says IDK what that is, man. Okay, we could probably make it so as soon as this first input isn't C or F, we could cancel it or exit the program, but oh well. So let's give an actual one from what's freezing? 0 freezing, and we're giving it in C. We're converting to F. Oh look, I did it wrong again. Yeah, we got this error because I gave a number. Let's try it for real this time. All right, what is your temperature unit of measurement in C? What is the temperature you are converting to Oh man, I just realized this doesn't make sense. What is the temperature? Oh, never mind, I just can't read. What is the temperature you're converting? 0. And there we go. 0C in F is 32. And then let's try it the other way. So 32, the temperature is Fahrenheit, and we're converting 32 degrees Fahrenheit, which should be 0C. Okay, yeah, something was done wrong. Let's see. Oh, look, right here. I timed it. That's supposed to be subtraction. Third time's the charm. So from Fahrenheit, 32 degrees, we get 0. Now we're converting properly. Well, that's it for today's lesson. I hope you enjoyed the video and I hope you learned something. In the next video, we'll begin diving into OOP, otherwise known as object-oriented programming. I have no idea if anybody calls it OOP, but it sounds fun. We'll discuss what classes are and how to create them in the next video. I'll see you in the next lesson.